Okay, y'all are in Integrated Corridor Management session for ITS Carolina's virtual meeting. Thank you guys for joining us. We have a couple of housekeeping things. We will, if you guys will stay on mute while the presenters are presenting, we are going to, each presenter will have a little spiel and we will allow questions after that presenter. Questions can be done via the chat function. So if you want to enter your question in the chat and then we'll read it and talk about it, or if you would like to ask the question yourself, we will make an opportunity if you will raise your hand. I don't know if y'all know how to do the little raise hand button. Under reactions in the Zoom, you can raise your hand. If y'all will raise your hand, we'll let each person ask their own question if they would like. After each presenter. A couple of reminders. There is the raffle. So it's $5 for a raffle ticket and it supports the ITS Carolina Scholarship Fund. And the winner receives a $100 Amazon card. So y'all join our raffle and that's on the Hoover website. You can sign up for that. Let's see. We are going to attempt to do vendor networking again, since that did not go as smooth as we had hoped. So there will be a vendor networking opportunity Tuesday, which is today, 4:30 to 6:30, which will also be the same hours as our happy hour. And happy hour, you will have the opportunity to play, let's see, you can do a, what were the choices? Let's see if I had them written down. Amanda, what were the choices for tonight's happy hour session?
There's 2 escape rooms, there's 1 category, and 1 trivia.
Okay, so I think that'll be a lot of fun if y'all can join us from 4:30 to 6:30 tonight for either vendors or happy hour. Okay, we will go ahead and get started with this session. Again, this session is being videoed, so just keep that in mind. Raise your hand or type in the chat box for questions. And Cole has a brief introduction of the Ops Academy. So hang on just a minute and we'll start our presentation. Okay, Cole, would you like to talk about the Operations Academy?
Sure. Good morning, everybody. This is Cole Daggerhart. I'm helping lead our ITS Carolina's operations training program. I know you've probably heard me present about it. Maybe, I think it was 2 years ago now, and we had a number of folks apply for our first class, and then everything kind of got put on hold with COVID and whatnot. So I wanted to give an overview of the program again for those of you who are not familiar with the program, and those of you that are involved with it, or maybe want to apply for a future class. So the idea is that it's a 3-year program and that we would do 3 training modules or sessions per year, that there are 20 participants, so a pretty small class size, and those participants have been really a split between private sector and public sector participants, about an even split there. And our goal for the program was to have some in-person training and network elements tied with hands-on experience. So if you can imagine a arterial operations module, we would definitely want to be spending some time out at a signal cabinet somewhere, and either the whole group or in small groups together, getting some hands-on experience. So we want it, because of that in-person and hands-on idea or around the modules, we've really just kind of put the program on hold until we can all start meeting together again. And so we think that'll be here pretty soon. So the first class will have their first session in the summer of 2021, and we're going to focus on integrated corridor management for the first session. So what you see in today's presentation, we thought this would be a good place to kind of jump in and give a little overview of the training program, because for that first session, we're going to be covering a lot of the things that we're discussing today in more detail. We'll have some additional upcoming sessions. Right now, we think those are going to be the advanced freeway operations, and we're evaluating the potential for a regional operations academy to talk about leadership and systems engineering, TISMO, and the capability maturity model. We do anticipate having our next class start around this time next year. So we'll start accepting applications prior to next year's annual meeting. So stay tuned for that. And if you're interested in applying to the academy, look out for those emails in the future. Back to you, Carrie.
Thank you, Cole. Our first speaker is Matt. And Matt is the NCDOT's state signal systems engineer and oversees the signal system timing and operations group, which is responsible for the efficient coordination and operation of North Carolina's nearly 400 signal systems. During his 10 years with the department, Matthew has worked in the fields of traffic safety, access management, traffic operations, and signal systems operations. In his current role, he's involved in many new and upcoming technologies in the ITS and signal operations fields, including high-resolution data, advanced traffic signal performance measures, advanced traffic management systems, and integrated corridor management. During the COVID-19 quarantine, his newfound hobby is building and flying FPV quadcopters. It's nearly as much fun as signal timing. I find that hard to believe, Matt.
I said nearly, not all the way. Let's see. Thank you, Carrie.
Yep.
Let me know once you give me control.
You should be good.
All right. Awesome. All right. Thank you, Carrie. So good morning, everybody. Like Carrie said, I'm Matt Carlisle. I'm the State Signal Systems Engineer, and I wanted to give a pretty high-level overview of what integrated corridor management is and what we've done over the last few years in North Carolina with it before the rest of the panel kind of gets into some of the nitty-gritty details. So let's see if my presentation will go forward. So the first thing that we need to do is give a definition to ICM. So in North Carolina, we consider it to be the integrated and proactive management of existing infrastructure along major corridors, which is a nice little one-sentence description of what it is. What does that actually mean? It is the, oh man, my presentation's going super slow. Sorry, guys. Awesome. It's the coordination of our transportation assets and our stakeholders engaged in corridor mobility, with the primary goals being the faster and better traveler information and stakeholder coordination, as well as faster incident response, and to dynamically manage our network based on the demand. I want to show you some of the tools that we use for ICM, and we scale these tools based on our traffic impacts. So whether it's a temporary single lane closure on a 2-lane rural road, or a multi-year freeway widening project where we have narrowed lanes and barrier on both sides, we have a lot of different tools at our disposal that we use to address those impacts. So right down here at the lowest end, we have traveler information. So this is pretty much just putting messaging out on drivenc.gov and through Waze and some of our other partners. Coming up a step from there, we have pre-planned detour routes, as well as some pre-planned DMS and CMS messaging. Coming up another step from there, we have pre-planned alternate routes and additional static trailblazers. So the detour routes are used when we have essentially full closures and we have no no alternative except to divert traffic, whereas alternate routes are used when we have something less than a full closure, but we think that we might have some available capacity on a parallel route. And the static trailblazers can be used on either types of route to help direct traffic along those alternate or detour routes. So there's an example there for our I-5111 I-40 widening project here in Wake and Johnston County, where we have these static trailblazers a lot further away than would be typical from our freeway to help guide traffic back to the freeway. Additional ITS devices, this can be cameras, DMS, CMS, or upgrading traffic signals, as well as expanding some IMAP routes. Additional IMAP resources, that could be additional drivers, additional trucks, and coordinated arterial signal timing is the development of dedicated signal timing plans to accommodate traffic that we divert off the freeway. Contract tow programs in lieu of rotation tow programs, and changeable trailblazers. So the changeable trailblazers serve the same purpose as the static trailblazers, but they're a little bit more dynamic because we can decide if and when we change the direction of that arrow. So 99% of the time, the arrow on the LED panel would point the same way that its previously static sign would point. And then when we need to divert traffic, we can change the direction of that arrow, typically to guide traffic past an incident before they get onto the freeway. And then the culmination of some or all of these tools come together to be our comprehensive response plans. And that's really at the core of what ICM is our comprehensive response plans and deciding when to use them. So now that I've shown you some of the tools, I want to briefly kind of show you what it actually looks like in practice with and without ICM. So this would be like a typical incident response on a freeway without ICM. You see that we have a parallel arterial there with some traffic signals. So first, the incident occurs and congestion builds. That congestion grows and law enforcement arrives. Law enforcement will divert traffic. It may or may not be along a viable detour route, but it will provide some relief. TMC learns of the incident and deploys IMAP, traveler information, and DMS messaging, again, providing some relief. The TMC, if necessary, can plan a viable detour route. However, directions along that route are typically difficult, if not impossible to give, because we're probably not going to have devices in all the right places that we might want. A rotation wrecker arrives and they are paid by the hour, so the removal time is typically kind of lengthy. And then finally, where available, municipal staff can reactively adjust signal timing. So if we're lucky enough to have the route go through a municipality and some or all of those signals are on a centralized signal system, we can get in contact with them to have them make some changes to the signals reactively to try to accommodate that traffic. So again, this is a lot better than if we did nothing at all, obviously, but it's not quite as robust as a full ICM response. Now let's look at what that would look like. So an incident would start the same way. Incident occurs and the congestion builds. That congestion grows, law enforcement arrives and notifies the TMC. And this is one of the first diversions from the previous slide that you'll see. We try to focus a lot on stakeholder coordination. So law enforcement, we would have had a lot of previous conversations so that they would know that this is a particularly sensitive area and that we have a lot of additional tools in our tool belt. So they'll let us know as soon as they can so that we can get things, get the wheels in motion. TMC deploys traveler information and IMAP, providing some relief. Just like we will hopefully be more proactively notified, we will also proactively notify a contract wrecker and municipal staff. So again, that's that stakeholder coordination. And step 5 here is a really big one. So the TMC would execute the planned detour, alternate routes, and signal timing. So what you'll see here is that we have some additional either DMS or CMS signs that are in place. That's because we would have planned in advance where we would need all of our various devices. We would also have planned exactly what the messaging will be on those signs so that the TMC operators can just click a few buttons rather than having to think about what the messages need to be and program them and push them. It can be done a lot quicker. We also would already know exactly what route we're going to use based on the various parameters of the incident that has occurred, and we would have upgraded all of these signals along the route to be on our on a centralized signal system, probably our statewide centralized signal system, so that we have communications. And we would have already developed pre-planned coordination plans specifically targeted for these movements to carry that traffic. So this is as close as we can get really right now to an easy button. It's more like 2 or 3 easy buttons, but it's a lot better than manually having to figure all this stuff out and program it and get it implemented, and provides significant relief compared to kind of having to react on the fly to every situation. And step 6 is very important as well. So a contract record arrives, and so versus a rotation record, the contract records have a financial incentive to get on scene quicker and to clear the incident quicker. So we've seen dramatically reduced clearance times so that we can better manage traffic while we have the incident still on the road, and we can also clear the incident quicker. So the primary improvements there over no ICM are the rapid stakeholder notification, a more coordinated and proactive response, better use of our network, and a focus on quick clearance. So the places where ICM makes sense, number 1 is locations with viable parallel routes. If we don't have viable parallel routes, then yeah, we can still do contract tow program, which will help quite a bit, and we can do some pre-planning of messaging and that sort of thing. But where we really get to reap the large benefits is where we have locations with viable parallel routes. And also we're looking at areas that have that are especially sensitive to reduced capacity. So these are locations that are already at or near capacity. We've been targeting largely so far TIP widening projects on the freeway. So typically the reason we're widening a freeway is because we're at or near capacity. And also locations with reoccurring congestion and with incidents occurring quite often as well. So the projects that we've done in North Carolina, we've done quite a few. So the first one that we did was Business 40 in Winston-Salem, and we kind of refer to this one as ICM Light because it's the first one that we really did. We were not quite dipping our toe in the water, but it was the first one that we did. So we've learned a lot of lessons since then. We have some additional tools that we use, and we've also gotten a lot more efficient at getting those things designed and put in the field. We also have I-26, which is currently under construction, and the ICM aspects of it are fully implemented in just south of Asheville. We also have I-40 south of Raleigh. Same thing, it's under construction, and we have all the aspects of the ICM have been implemented here for a year or so. We also have in design I-95 north of Fayetteville, as well as I-95 south of Fayetteville. So there's 3 different TIP projects in that area. We essentially have 2 different ICM projects that are covering those 3 TIPs. And then finally, we have I-85 west of Charlotte, which is the only standalone ICM project in the sense that it's not being done in conjunction with a freeway widening project, but we actually got some CMAQ funding from Federal Highways specifically just for ICM because it's a very busy section of I-85, and we have incidents occur quite often. And finally, I wanted to talk about our accomplishments. So let's see, about 3 years ago, aside from having a Business 40 ready to, getting ready to go in, I believe at the time, and some pretty early design work with the I-85 project being done, we hadn't done a tremendous amount with I-85, so or with ICM. So we've come a long way in the last few years. So since that time, we've gotten 3 projects actually implemented. We have over 130 miles of freeway that are covered by those projects. So what that means is that anytime an incident occurs in those 130 miles, we know how to react and have a very robust reaction in just a matter of minutes. We have over 200 signals that have been upgraded to be on our statewide Centrax signalized system. And we've installed over 50 dynamic trailblazers, or will be installed very, very soon. So I'm just counting all 50 right now. We also have 2 NCDOT managed tow contracts that are in place, as well as some additionals coming down the pipeline. But perhaps an even more important than the hardware that we've gotten out on the ground and the decisions that have been made is the improvements that we've made and the documentation that we've made to the actual process of developing and implementing an ICM. So again, 3 years ago we had done some work, but we had done very little in the way of actually documenting how to do it. And I think if the right set number of maybe 6 people just disappeared, then we would have had to start from scratch. So luckily we have now documented a tremendous amount of the process so that it's not relying on just a handful of people that have the knowledge in their heads. So the first thing here is the project process outline. This is I think 20 or 30 page document that is still sort of in draft form, but it's getting very close to being finalized, I would say. And this documents from A to Z everything that needs to be done. to the best of our current ability anyways, for an ICM project, from as early as the planning, when you're looking at, 3 or 4 years from now, we're going to let a freeway widening project. Here's what you need to start doing now, all the way up to the actual implementation, the testing, the after action reviews, the fine tuning, and also the long-term maintenance of the system. We also have our decision matrix tables, which are the 2 spreadsheets you see on the left side. And these aid us in deciding what to do based on the various parameters of an incident. Well, I'll come back to that. And then the ICM response database, which is the, let's see, third from the left with the purple background there. This is where every decision that has been made for an ICM project, and pretty much every aspect of it, goes into this one single database. And this is what our TMC operators use to actually operate and implement an integrated corridor management project. So they can open up this database when an incident occurs in an area that is covered by ICM. They put in 5 or 6 parameters of the incident, like what time of day is it, what day of the week is it, how long is it going to last, how many lanes are closed, how long is the queue, all those types of things. And they instantly get an answer essentially that says, go into Centrax and turn on this signal timing, go into Vanguard and turn on this message set, call, this tow company, call these other 2 or 3 people that have to do, XYZ special thing. And it's just, it's really streamlined the actual implementation of a response when we have an incident. We've also standardized the training across our TMCs. Brian Gunter and his team have done a great job in training all the TMC staff on how to use the database and what the purpose of ICM is, when it needs to be used in a general sense, as well as very project specific when we have a new project come online. And also we've standardized our after action reviews so that after we have an incident, we get back together a week or 2 later, we get all the stakeholders in a room, although at this point we're obviously doing everything virtually, and we talk about what worked and what didn't work. And that has proven to be tremendously helpful. I think that we've identified some weaknesses in some of our decisions that we've been able to correct. We've identified some technical glitches and issues that we've been able to correct. And it's also helped us streamline some of the planning and design side after we've actually implemented it and seen some of those things that work and don't work. Sorry for the dramatic long pauses. I'm waiting for waiting for my presentation. So coming soon, we have 3 additional projects being implemented this year. So that'll take us from 3 to 6. We also have 3 Centrax server to server connections that will be made. So again, I talked about our signals being upgraded so that we have remote communications with them. We are also connecting the statewide, NCDOT statewide Centrax server to Gastonia, Charlotte, and Fayetteville for various ICM projects, so that for all intents and purposes, they will act as one large system, so that we don't have to, call Gastonia or Charlotte and say, hey, turn on, this signal timing on these 3 different signals. The TMC operators can just click a button and it sends all of the right messages to all of the correct signals, regardless of whether they're a Charlotte signal or a DOT signal or a Gastonia signal. And finally, things that we're still working on are continuous improvements. A really big one is reducing our overall timeline. And we've already done this a lot. I think that 2 or 3 years ago, it was probably taking 2 or 3 years from kind of initial conception to actually getting something implemented. I would say we've gotten that down to as short as maybe a year or less at this point, and I think there's still some room for improvement. And again, a lot of that has to do with documenting the process and how to do it. We're refining our signal timing philosophy. I won't go into great details on that, but essentially we sort of started out coming at it from one angle, and I think that we have some different approaches that will hopefully make the actual signal timing itself even more accurate than it might have been previously. As I mentioned, we're streamlining our decision-making process. So when we originally started these, we were making literally 2,000 or 3,000 decisions for every specific type of incident for a corridor. And now we're trying to come up with a set of rules to make those decisions for us, so it can essentially get the same end result with a lot less work on the front end. And finally, traffic operations is getting involved in TIP projects a lot earlier. This is partly due to the IPD, the Integrated Project Delivery Network project that's going on right now, but it couldn't have come at a better time because the integrated corridor management is a reason that we really need to be involved at the front end, and we continue to get involved in TIP projects much earlier than we have historically done. And with that, my 10-minute presentation only took me about 30, and I will turn it over back to Carrie.
So thank you, Matt. That was a general overview of ICM and everything that's going on in North Carolina. What we're going to do from here is break it down into specific sections and talk about like each of the pieces. Does anybody have any questions for Matt? There weren't any entered in the chat box. Let me scroll through real quick and make sure nobody had their hand raised. Maybe. Okay, so we will go ahead and give Amanda the floor. And Amanda Good is with Kimley Horn, and she's an ITS planner and a project management professional. She has 17 years of experience focusing on advanced, connected, and autonomous technology, systems engineering, state and regional ITS planning, and operations support. This includes developing and implementing plans that leverage future technologies to better support operational strategies and foster multi-agency collaboration.
All right, hopefully that works. Good morning, everybody. As Carrie mentioned, I'm Amanda Good with Kimley Horn, and I am the project manager for the I-85 Integrated Corridor project. And as Carrie mentioned, the focus for my piece today is going to be on that stakeholder communication, coordination aspect. So I-85 ICM is between exit 10 and 33 along 85, going both north and southbound. So a little under 25 miles, and US 74 is the alternate route or the parallel route, as Matt had referred to. So after we came on board, one of the things that we needed to do was look at the existing conditions. Well, see if it'll, oh, too far. Okay, so I am not clicking anything.
You have to be extra patient.
Okay, so one of the things with the existing conditions is we were notified that there were at least 10 planned projects in this area. Of course, we were aware of the widening project on I-85, but there was also a widening project on US 74. There were several bridge projects. There were some intersection improvement projects. And then once we got started, there was a streetcar project. So one of the things that we had to do was not only coordinate for the ICM project, but also keep in mind all of these other construction projects, what phase they were in, when they might come into construction, were there going to be any impacts to the ICM project, what sort of impacts were they going to have. As we continued through the ICM project phase for us, unfortunately, some of these projects were either put on pause or they were pushed. So their impacts weren't as, they were minimized as considering from the original impact that they might have had. And then of course, we have to look at all of the infrastructure that's both on 85 and 74. So of course there's signals. Well, there's 3 different networks. You have the Gastonia signals, you have the DOT signals, and then you have Charlotte signals. So that's another thing that we had to contend with. And then of course there's cameras both on 74 and then on 85, and then looking at what sort of DMS that we had that we could then be able to provide some traveler information later. For responses to incidents, there's the Highway Patrol, and then you also have Gastonia and Belmont Police Departments for 74. So that's another thing that we had to coordinate just from an impact. We had to let those folks, the law enforcement, know, hey, if an incident were to occur, this is what's going to happen, and this is how it's going to impact this area, and this is how it's supposed to work. And so there was a little bit of coordination on that. And then of course there were already existing detour routes. So not only are we looking at alternate routes, but then do we need to incorporate the detour route? So that was a question that we had asked, and it was a very fluid decision because we kind of went back and forth with that. And so ultimately we did include the detour routes, but that was just something that we had to also coordinate with. So after we have the existing condition, one of the other things that we have to look at are the actual ICM system. So what is it that we need to implement? So again, we're working with the stakeholders. We're looking at what is actually existing in the area. And then we wanted to consider, well, what do we want to install? What do we want to implement? So we decided that we would go ahead and implement some cameras because we were talking to operations, and operations said, we have some blind spots. We need to be able to see what's happening. Then we wanted to incorporate or install some DMS. We needed to be able to coordinate with providing traveler information to the motorists so that they could provide some, so we could give them the decision points. They needed to be able to make a decision before it was too late. And then, of course, as I mentioned, there's 3 different signal systems. And so we needed to coordinate with each of the municipalities to figure out how are we going to coordinate all of that together. And we'll go back. And how does all that work? And so we initially had one idea, and of course, through coordination with all the stakeholders, we came up with a different plan at the very end. And then, of course, once you're on 74, how do you keep the stakeholders moving? So again, this was, a more conversation, a discussion, and that's where we decided with the changeable trailblazers, and I think Cole is going to go into a little bit more about the design of those and how they actually work. So who are we coordinating with? Well, we're coordinating with some stakeholders. Who are those stakeholders? The stakeholders are essentially DOT, Gastonia, and Charlotte. It's that easy, right? Well, not exactly as easy as you think. So first, we have invested partners. So in this area, we had some folks who had a very invested interest in what was happening in the area, both from Belmont and Gastonia. And so we needed to hear what their opinions were and what they would like, and we had to incorporate or think about what that was. We also have 2 consultants. Contractually, we're not partners, but as a whole project, we needed to work together. There was a lot of coordination between the signal timing, which AECOM did, and then the design and operations that Kimberly Horn did, and one impacted the other, so there was a little bit of coordination with that. Well, then, of course, you have the statewide operations looking at how does this operate? What are some of the things that we need to consider? But then, of course, you have your statewide signals, the signal timing, so you can't leave out Matt and his group. So that was, of course. And then, of course, you have the different municipalities. You have Gastonia, you have Charlotte, and then you also have Belmont. So even though Belmont, their DOT signals, they still had a vested interest. We are putting traffic on US 74 through Belmont. And so there is a vested interest for them to understand what ICM was and how it was going to work and how this hopefully was going to help alleviate some of that congestion during the incidents. You also have the ITS design group. Again, we had to design some infrastructure that had to be put onto the roadway. So they were the ones that were reviewing and looking back at what we were doing and approving. You also had the Division 12 traffic engineer. We're in Division 12, but you know what? we're also in Division 10, so we had to bring in both traffic engineers to have their opinions, their discussion, making sure that what we were doing was going to be working for everybody. You also have, from an operations perspective, you have the Metroline and TMC. They're the ones that are going to operate this. How does this work? We needed to make sure that they understood what this was. How does it? What's going to happen when they implement it? And then, of course, during off hours, you had the STOC who's going to operate. So again, you had to coordinate with them to ensure that what we were doing was also in line with what they understood. Of course, during all of this time, we had multiple Division 10 regional ITS engineers coming in and out. So there was a lot of coordination to get those folks up to speed on what we were doing, and to also make sure that they understood, again, what this project was about and what we were doing and how it works and what impacts there were going to be. So again, also with the law enforcement, what we decided to do was have an education session with them where we presented what ICM was, what the impacts were to the law enforcement folks, what we would like for them to do, what we are hoping that the system would do for them. So there was a lot of education and a little bit coordination and making sure that they were aware of the stakeholder meetings and inviting them and letting them hear how we went through this whole process. And so I think they attended most of the meetings, and they brought very valuable information to what was actually happening in the area to help with some of those responses. Of course, when you're having Gastonia signals, you need to create some memorandum of understanding. So we had to work with the program management office to draft up some MOUs that we would then work with Gastonia to ensure that when the ICM is implemented, then Gastonia would say, okay, we're not going to touch this until the ICM is complete. And so that was where we had to then coordinate with them. We then also decided to put this project out to bid. And so instead of working with Division 10, we ended up working with instead of working through Division 12, we worked through Division 10 program delivery on the construction piece of the project. So working with them to make sure that we had all of the forms, all of the plans, everything that we needed for the actual the bid. And then of course you have the contractor. So once the contractor was on board, they had lots of questions. We also made some changes. So there was a lot of communication on what was expected and what was done and what needed to be done. And so that was a very fluid process. And then of course, now that everything is constructed and we're ready to actually go live here soon, hopefully. We are coordinating with the public information officer for both Division 10 and 12. And so we wanted to provide as much information that we could for them from a history background, for what ICM actually is, how it works, everything that is coordinated with that, so that they could provide any media information to the public. And then of course you have the public, they're the stakeholder as well. What we provide and how we provide it will help them determine what sort of response that they're going to have and how they're going to maneuver around an incident along 85. So what information we give them on the freeway to then route them off onto 74, and then how we route them back is very important. And so that's another consideration that we had to figure out what sort of impacts we were going to have. And so once we determined all the stakeholders, the next piece was actually identifying what the response scenario components were. So we were invited to another ICM project response decision matrix sort of meetings. There were several of them. They were very long, and what we decided for 85, and we also did this for 26 as well, is let's figure out a different way. Let's figure out how we can make this a little bit more efficient. What do we need to do? Who do we need to coordinate with? And so we were able to, as Matt mentioned, develop parameters or the rules. So through the coordination of some primary stakeholders, we were able to have some shorter conversations. We were able to identify those parameters that then helped us figure out what these response scenarios were. We also had originally 14 response scenarios, and based on conversation and the fluidity of the process, we incorporated the detour routes, which then expanded our response scenarios to 20. We had an extra 3 in both northbound and southbound. Then you, of course, had your coordination with the operations centers to develop the message sets. We needed to make sure that everything was consistent with their standard operating procedures for developing messages. And so there was some back and forth between them to ensure what we were developing actually is what needed to be developed. And then, of course, the timing plans. This is what, as I mentioned before, AECOM was making sure that what responses we had the correct timing plans associated. There's a whole slew of action sets that needed to be developed, and this all needed to be coordinated between what responses were going to be done and when and how. And so there's a lot of additional details that go into 85 did not have a tow contract, so that was something that's not included, but it is included in the other projects. Once all the information was identified, it was put into some tables. Those parameters were used to help identify those tables. And so when those tables are done, they're put into the database, and then you have to get, and one of the outputs for the database are these maps. So the map on the left is, with the red, is an incident occurs between exit 19 and 21. And then on the right, you have the incident occurs, or the response is the alternate route from 10 to 21. So the purple is the alternate route, and then the pink is the detour route. So this is all what's provided to the operators when they actually enter all the information in. This is just an example to show some of the things that we had to work through and provide. And then once everything is set in the spreadsheets, this is just a snapshot of all of the spreadsheets that we had to create. So you have your turn by turn for the different alternate routes. You have your signal timing, you have your changeable trailblazers, you have your responses, you have your incidents. Essentially, you have all of your inputs that the operator would put into the database, and then you have all the outputs, and all those outputs had to have some specific coordination with specific people. And some of them, it spanned multiple people. Some are just like, hey, STOC, how do you do this overnight? Or, hey, Metrolina, what do you guys do when this happens? And there's a lot of coordination with Division 10 and 12. All of these spreadsheets were put together. They were provided to all the stakeholders. We wanted them to review. We wanted to make sure that everybody was good with what we were developing, and that through some verification process, we hope that everything will still be good. So once we get the go-ahead from Matt, we'll go ahead and schedule the verification process testing. And what we'll do is we'll identify some incidents. We'll take all of the primary stakeholders together, and we'll go through those incidents. We'll see what is inputted into the database. We'll see what outputs. We'll make sure that that's actually the response we want. And then we'll go through and ensure that the messages are correct, that the signals that are involved in that response are correct. So that, again, another coordination piece, another part where we're involving a lot of different people. And so ultimately, we have lots of different stakeholders that we had to coordinate with. It was a very fluid process. It changed not dramatically, but it did change a lot from the beginning to the middle to the end. And then, of course, we have our final ICM decisions that we hope are the most appropriate and most efficient for responding to an incident that's on I-85. And I'll turn it back to you, Carrie.
Thanks, Amanda. And sorry, y'all, my mouse died in the middle of that presentation. I'm sorry about the technical difficulties. So now you guys get to see my fingers for the rest of the presentation. Does anybody have any questions about Amanda's presentation and all the involvement that went into stakeholders and developing the scenarios? I'm going to assume that's a no. And keep going. We would love audience participation if y'all are up for it.
Carrie,
Yes.
if anyone has questions, you just want them to raise their hand, I guess?
They can either raise their hand or type it in the chat. Matt,
Okay.
Do you want to go ahead and answer Sean's question, or do you want to wait until Steve talks about signal timing and come back to it?
Let's do that. Yeah, I'll just wait until Steve talks.
Okay. Did anybody, I don't see anybody raising their hand. Is anybody else? Okay. Our next presenter is Cole. Cole is a transportation engineer and TISMO specialist at Exalt Engineering. Cole has over 13 years of TISMO experience, including planning, design, procurement, integration, operations, and construction administration for ITS systems, traffic signal timing, parking systems, and transit systems. Cole focuses on implementation of sustainable technology solutions supporting long-term operations and maintenance efficiency. Give me just a second to mute myself and I'll hand it over to you, Cole.
Okay. Thanks, Carrie. Here we go. So I'm going to be talking mostly about response plan development and trailblazer design. And I'll try not to touch on the pieces that Amanda and Matt have already covered. So my role with NCDOT's ICM initiatives is being the project manager for I-95 ICMs, and there have been two projects. So the first project is between exit 52 and 87, and it ties closely with I-5986A and I-5986B TIP projects, where they're widening I-95 from a 4-lane section to a 6-lane section in that area. And the second project is between exit 13 and 40 on I-95, and so that one's just getting started. And it's related to the I-6064 and I-5987 TIP projects, also widening I-95 in the area from 4 to 6 lanes. I-95 is mostly in a rural area. It does go through Fayetteville, and there's some close by towns such as Benson and Dunn, Lumberton as well. So there are some smaller cities and towns in the area, but primarily the routes that are being used on these sections are along rural 2-lane roads. So it's a little different than some of the other ICM projects, and so we had to kind of mold our approach for response plans and route development for this project. So my specific responsibilities were with stakeholder coordination, the route and response plan development, trailblazer design and implementation support, supported Doug Hayes, who you'll hear from later a little bit, with tow contracts, and then maintenance planning. So with each of these construction projects, there are periods where ramps are closed or whole interchanges are closed. There are, in the beginning, there is barrier on both sides for the full length of the project, and then as the project completes construction, the barrier starts to come out on either the northbound side or the southbound side. And so maintenance is not the typical maintenance that you would think of, like fixing devices as they break. It's more related to how do we maintain ICM on the corridor through all these different phases of the projects, and then into the future as the projects end. So again, I'm going to focus on the two that are highlighted in orange here: route and response plan development, trailblazer design. So for route and response plan development, it starts with, on both of these projects, it started with a really simple Google Maps, where we laid out, here are some potential parallel routes for the corridor. And you can see that along I-95, and this is for the section from 52 to 87 here, you can see there's a great parallel route in US 301 because it's so close to I-95 all along the corridor. And I'd say the only downside there is US 301's a rural 2-lane road. So we had that as just something to overcome with the project as well. We also have a US 13 that you can see here, which intersects with US 421 and Interstate 40 as a kind of a longer option, a longer alternate route option. And so route development really is just a coordination effort between STOC staff and division staff to, and this is in divisions 4 and 6. So there's a process we went through of just discussing, hey, what routes do you normally use for incidents in this area? How have you seen those work? Are there trouble spots? Where are we going to have problems with geometry, signals, 4-way stops? Are there schools along some of these routes that may impact alternate route traffic in the AM peak hour? Are there any points of confusion along the route? And so we just got together and really kind of talked through this and talked with folks that are experienced in managing these corridors on a day-to-day basis. We then rented a big van and all got together and went and did a ride through of the corridor. We looked at each location. We looked at locations where we may need trailblazer signs. We looked at each signal and basically just kind of rode through and said, okay, we've got a plan in our head of how we might lay these routes out. Will this really work? And so that was very helpful from the perspective of gathering all the subject matter experts together and riding through the corridor. And so the route development then transitioned into response plan development. And Amanda's already talked about this a little bit, as well as Matt. You saw a picture of one of these decision matrices earlier on a slide that Matt had. But really, we looked at a lot of different factors for each section of the road that may be closed. So is one lane closed and one lane open, or are both lanes closed? Is it a weekday or a weekend? Do we expect the duration of the incident to be less than a half hour, between a half hour and 2 hours, or more than 2 hours? Does it meet a Q threshold? And a Q threshold can be defined depending on the area of the road you're looking at. But in general, our rule of thumb was 5 miles. If the Q has backed up 5 miles from the incident, we may need to go to a more intensive response plan than if it's a shorter queue. And so we looked at these things and developed, we assigned a route to any specific scenario or set of conditions. We developed message sets for DMS and CMS, sign scenarios, as well as trailblazer scenarios, which are associated with these, to assign to the routes. And then again, signal timing action sets, which Steve's going to talk a little bit about later. So which signal timing plan should we use depending on the route that's been developed. And once we settle on a response for each specific scenario, and we had 48 routes that were used, or I'm sorry, 48 response plans that were used along this one ICM project. And this is an example of kind of the output of that. You know, when we have an incident between exit 61 and 65 on I-95, we can divert traffic to the route that we've named northbound 61 to 65, because traffic's exiting on 61 and make a right on 301 and then come back at exit 65. So you can see here that we've highlighted the static trailblazers along the route. We've highlighted the dynamic trailblazers that would have to change for this route, as well as the signals where you see a signal timing plan would be implemented to prioritize the right turning traffic at both of these intersections and really flush the arterial for the interstate traffic. So this is an example of a scenario where perhaps there's one lane closed and one lane open, or maybe it's two lanes closed, but it's the queue threshold has not been met. And then once the queue threshold is met, once we're seeing that this traffic is backing up on the order of about 5 miles, we would, typically this occurs when there's two lanes closed, so we would still be pushing traffic off of exit 61 and using the short route, but we're also initiating signage to use a long alternate route along US 13 to US 421, and trying to get additional traffic to divert off early and use this long route to disperse traffic a bit more. Here you can see some of the changeable message signs that would be used along the corridor in the message sets. You can see some of the dynamic trailblazers along the corridor, and both the short route and the long route had their own signal timing action plan. So those would be implemented in accordance with the plan for each route. So another piece of the project is trailblazer design and implementation support. This is a picture of some of our trailblazer plan sets. Not super exciting, but you know, there are static trailblazers, which Matt mentioned earlier, used along a number of different routes, and the majority of the trailblazers that we're designing are actually static. But we also use dynamic trailblazers at locations where, for example, I'll go back. Let's see if it'll go back one more. There we go. So example on the, oh, went too far. On 301, 301 is used as an alternate route all along this corridor. So you can see here that these dynamic trailblazers are being changed because normally they would tell you to turn right to go get on I-95 North. But here we're changing them to tell you to continue going straight through because there's an incident. And so we don't want to direct traffic to make a right here to get back on I-95. So those dynamic trailblazers can be controlled in one of two ways. The primary way that they're controlled is through integration with the traffic signal at the intersection. So if there's a traffic signal at the intersection, the trailblazer can be wired into the intersection and be a phase associated with the signal timing plan. For locations that are in the middle of nowhere along rural routes, there's no signal, we had to develop a new design for that, and our idea around this design is treating a changeable trailblazer like a small dynamic message sign, where it has a controller built in, it has a modem that connects it to say a DMS messaging software, and so we're able to push with a message set, push an arrow to the sign, almost like a message to a DMS to display the arrows. And so another aspect of the project is implementation support, so developing procurement and supporting Division 6 and Division 4 with procurement of the trailblazers. So I wanted to give you some examples of challenges and lessons learned. This is an example in Benson. So you see this is I-95 on this side, and on the left side is US 301 going through Benson, and Main Street connects I-95 and US 301. And one of the things that we realized on our ride through, if you look at that Napa Auto Parts building there in the picture, that is on the northeast corner of the intersection of US 301 and Main Street. And while this route seems to be a good alternate route, it's close by, there's signals that we can time along NC 50 Main Street here in Benson. what we realized is that trucks can't make that right turn from NC 50 to US 301 North without a law enforcement backing up the traffic on that southbound side. And so it would cause so much delay that we decided that this wouldn't be an alternate route. So one of the things that we did take into consideration is that NC 50 would still be used by motorists who are using, Google Maps or Waze for to give them guidance. So they may still take this exit and use 301 as an alternate route. So we took that into consideration and developed an advertised route signal timing plan for vehicles that may use this route, but we didn't direct motorists to use this alternate route. A challenge with the trailblazers. So I mentioned the two types of trailblazers. You can see one along I-85 here, the I-85 ICM, and this one is tied in with the signal. You can see the signal in the background at the intersection. On I-95, where we were trying to do the rural trailblazers, one of the problems we ran across is that the industry really didn't have a solution for this. There wasn't a small dynamic message sign trailblazer with the integrated controller that you could tie into the DMS central software. And so we're working with a number of vendors to see if we can develop a qualified products list, a QPL item for these signs and get them in place. But we didn't want to let that slow the project down. So we moved forward with static trailblazers in a number of locations where we would have had dynamic trailblazers, and those will just be modified by field staff whenever we implement a plan until we can get these dynamic trailblazers up and running along the corridors. This is an example of another thing that you see in the field or really using a map while evaluating the routes. US 13 comes up through Newton Grove to get back on I-40 when we're using this long route, and it goes through this roundabout. And we were out here looking at this in the field and said, we've got to get I-95 traffic to take, not the first, not the second, not the third or the fourth, but the fifth right turn in this roundabout. How do we keep folks on track through this roundabout? And you can see there's a couple of folks from the STOC. I believe that's Matt there with the white hat on. We're all out there trying to figure out the best approach here. And what we came up with in the end was, for the folks that are going northbound, this northbound alternate route, and both of these routes aren't implemented at the same time, but if we're going northbound, we would have folks take this side street, a left early on, and then another left, rather than trying to get them to traverse the roundabout. On the southbound side, it was pretty easy to sign, to take the first right out of the roundabout on the US 13 alternate route. So that's an example of just kind of a routing challenge and how we solve that. One of the other things Carrie mentioned that we might want to talk about is just the most memorable aspects of ICM. And for me particularly, I really enjoyed, it always comes back to engineering. There's a lot of technical knowledge involved and design and whatnot, but it really all comes back to it's all about people. And with the decision matrix review meetings, it was just many of them were long and there were a number of them, and Amanda talked about this a little bit, but it was really great to just see folks with different backgrounds and expertise come together to pull together a great solution. So you had the STOC team, who they operate these routes, day in, day out. They had some existing detour routes that they used in the area. And so they had a lot of knowledge about how they would typically handle an incident on this route. And then you had, James Flowers from Division 6, and then Todd Lewis and Debbie Leonard up in Division 4. And they brought this terrific knowledge of, from boots on the ground. When an incident occurs, you know, which exit or do we route folks off on, and where do we route them from there? What doesn't work well? You know, when we have them make a left turn at this intersection, it's really difficult, and it doesn't work well. So taking their, you know, field knowledge and incorporating into the discussion, and then the operations leadership. So Dom Ciara Mataro and Jennifer Portanova and others on their team, listening to kind of, well, this is how we've done in the past, and this is how this works, and kind of providing feedback on, well, how can we make it better? Can we, I know we've done it this way in the past, but how can we do this to make it more efficient? Or, you know, rather than to try to bring it down from 100 scenarios to how do we bring this down to 48 scenarios that we can do really well. And so, and then the last one's the design build team. So while we're trying to do ICM, there's also a design build team that's working on traffic management plans and trying to manage the work zone. And so coordinating with them so that these efforts overlap and complement one another was also a really cool aspect of the project. And then, you know, real impacts. One of the things that's really cool about signal timing, and Steve's going to talk about signal timing later, is that you can kind of implement a new signal timing plan, and immediately you can drive through the corridor and see improvements to congestion reduction or safety enhancement. And I think that's going to be true of ICM as well. You know, as soon as we implement these routes, I think we'll be able to see huge impacts to congestion and safety along the road. So it's going to be really cool to see that. This first I-95 ICM project goes live on April 20th. So we're really looking forward to seeing the results of this project.
Thanks, Cole. We have a couple questions, so we'll go through these questions real quick first, and then go on to Steve's presentation. Let's see, let me scroll up a little bit. On US 13, the southbound route, why did you not use the same as the northbound route, Cole? So yeah, why didn't you use that same route?
The primary reason is we were trying to keep all traffic on state route highways, and so we really didn't want to use that side street, but we just felt like it would be so confusing in this situation that it would make sense to use a non-state route street to bring that traffic around Dennis. So it looked to be an easier movement in the southbound direction, so we just kept it as it was. Good question, though.
And then Cole, after implementation of a new route, such as the roundabout, how do you know how the public responded to the new system?
So this hasn't been implemented yet. So I guess the public response. I didn't mention that one of the things that we're going to do, I think Matt did mention this earlier, is that after action review. So we'll all get together after we've implemented several of these routes and discuss how well did it work. You know, what worked well with signal timing, what worked well with the route, the message signs. Did we see the queue decrease? Did we see it increase? How did that tie in with what the tow contractor's doing? So we do plan to evaluate the impact, maybe from a public perspective as well as from a design perspective and operations perspective as well.
Okay. Doug wanted to point out that this is his third coffee, so he's bored to tears at this point, apparently waiting for his turn to talk. Let's see. After an incident, who decides to deactivate the dynamic trailblazer signs and when? Is there a criteria threshold, time delayed, incremental, or not all signs off at once? Matt, I'm going to let you answer that question, if you don't mind.
Yeah, so I can. It's an easy answer from me, anyways. For the dynamic trailblazers that are tied to traffic signals, so the way that they're operated, they're activated or deactivated is by turning on a signal timing plan. So essentially, if we have, let's say, plan 51 turns on the proper incident management timing plan that we want, and that would have associated with it changing the output to that trailblazer to turn the direction of the arrow. So, and I might be stepping on Steve's toes a little bit here, but I'll just go ahead and say it. The way that we're deactivating the signal timing is we essentially look at probe data to figure out for whatever alternate or detour route we are using, what the typical travel time is for that route. We're essentially taking like the 95th percentile time, so we're kind of chopping off any outliers and then applying like a 50% kind of safety factor, if you will. So if it typically takes 20 minutes, then we would set a deactivation delay for the signal timing of 30 minutes. So 30 minutes after we stop telling people to use that route, we would turn off the signal timing, which would also then change the dynamic trailblazers. For the ones that are not tied to signals, I think that we would probably use the same methodology and intent, but it wouldn't be handled automatically, if you will, by the signal timing. So I don't know if Cole, you've thought about that any, or how we're going to handle it, but that's how we're doing it for the ones that are connected to the traffic signals.
Yeah, I think for the ones that are connected through the dynamic message sign software, it'll be related to, we'll be removing those one by one, as is done for typical message sets on the freeway.
Yeah, and if I could just add to it, I guess that the intent behind that is so that the theory, anyways, is the last person that we tell, or the last person that takes an alternate or detour route per our guidance, they are provided our prioritized signal timing through that route until they get back to the freeway, so that we don't, we're not kicking a few hundred cars off the freeway and then just shutting off the signal timing right in the middle of their reroute.
Okay, James, yes, shoot me an email and I will send you some goodies from the 2020 meeting that we still have left over, and that can be your royalty if you'd like. And then we have one more question. It looks like, can you shed some light over the decision-making process of choosing Fayetteville? Gastonia and Belmont makes sense on US 74, but what was the decision-making process for Fayetteville?
So assuming this is coming to me for the connecting our Centrac system to them, a handful of the routes that on Cole's projects have some signals, just a handful of signals on the essentially extreme east side of Fayetteville that are part of those routes. And so the only way that we would have any connected communications to them from our TMCs is to connect their Centrac system to our system. So in the case of like Gastonia, we need, I don't remember, 30 or 40 signals that we need access to out of there, maybe 200. And in the case of Fayetteville, we really only need it for this particular purpose for a handful of signals, maybe 5 or 6, but that is why we are connecting to Fayetteville.
I think the other, why was ICM chosen along I-95 in this area? I think one of the things is it's a fairly incident-prone area, and so when you have barrier on both the inside shoulder and the outside shoulder, like will be needed for the I-95 widening in this area, when an incident occurs, there's just no way for the folks that arrive to the scene to move the incident to the side of the road. It's why Doug's going to talk about the contract towers here soon, but why that's so important and why it's important to have alternate routes that can be used.
Okay, thank you guys, and thank you for the questions. Next, we have Steve Haney. Steve serves as the traffic engineer for RS&H's North Carolina Transportation Infrastructure practice. He has experience in traffic engineering, ITS, and traffic signal systems throughout the Southeast. Steve's broad range of project experience has included traffic signal design, communication cable routing plans, CCTV monitoring systems, and way station feasibility studies. But his first engineering love is traffic signal timing optimization. So he is going to talk to us about the traffic signals as part of this. Steve, do you want control or you want me to flip through for you?
I'll take control. There we go, requesting. Is it going to come up here? There we go. Oh, you did. Oh, okay, you did something fancy with it here. All right, so I thought the best way to go through signal timing is just to compare and contrast the regular signal timing project with an ICM project. But first, some overall thoughts. You know, the big difference, the obvious difference, is just the sheer size and scope of the networks. You know, with a signal timing project, it's very defined box that we work within. Let's say that you know, you got 5 signals, you got 4 timing plans, and you're going to get 2 new TMCs, turning movement counts, for this project, and you work from that. With the ICM project, it kind of took on the feel of a congestion management project. We had to do some traffic volume synthesis. We analyzed multiple detour routes, multiple networks, and individual signals. We had multiple priority movements at each signal. For the I-95 ICM project, we had 31 signals, 50 detour routes, 93 priority movements, all within 3 divisions, or spreading over 3 divisions. You know, a note about the priority movements, in ICM lingo, we're calling it local level priority movement designs, or LLPMDs. Not the easiest to say. So for, let's say, an isolated signal, you may have a northbound through and you may have a northbound right LLPMD. And each LLPMD would have 2 levels of traffic associated with it, a high traffic and a medium traffic. So basically, the size of the project, it was just hard to keep things straight in your head. There we go. There is quite a delay, isn't it? Okay, so goals, you know, you set out the goals, talk with NCDOT in a normal signal timing project, and you can have a variety of MOEs. It could be minimum delay, you know, it can be maximum green band or maximum throughput, and that may change from time of day or time of year. But with the ICM project, you're mainly talking about maximum throughput for the detoured traffic without causing too much pain for the regular traffic.
For some reason, I think I'm going to have to click through it. I don't know why it's not working. Sorry.
Okay. Yeah, thank you. Okay, so for the signal verification or signal plan verification, there's not really any real difference. You go out and visit the site, you redline the signal plans, and you ensure that all the equipment's working. Next. With volumes, it's a big difference, and that's going to be what I'm mainly going to be focusing my time on. You may, yeah. Okay. So, you know, with a regular signal timing project, you get new turning movement counts for your critical intersections, and then you use historical TMCs for the other intersections, and then you apply a growth factor. At least before COVID, you did that. With the ICM projects, you have to deal with 2 types of traffic. You have to deal with the regular network traffic that's on your networks every day, and then you have to deal with the detour traffic that's coming through. You know, you're dumping interstate worth of traffic through a network. With the network traffic, in the ICM project, we're using a lot more historical TMC volume information off of the NCDOT website, just because, you know, the cost of collecting the TMCs. We did get new TMCs at a variety of important intersections that we didn't have recent TMCs. So with the detour traffic, like I said earlier, we need to determine a high detour volume and a medium detour volume. But first, what we needed to do is determine the volumes on the interstate. And we did that through, you know, a variety of methods. Sometimes we had actual 15-minute counts on the interstate at a particular, close to an exit where we had to fit for the detour. Other times, all we had were AADT, and what we did is just apply a D and a K factor to get an hourly directional volume. Like I said earlier, we needed to determine a high and a medium detour traffic levels. So with the high volume, we just decided that that was going to be a full interstate blockage. And whatever volume is on the interstate, that is the number that wants to divert onto the detour. With the medium traffic, it was a little bit more involved. We assumed that one interstate lane would remain open. So we had to determine, you know, what's going to dump off. And we found a Maryland DOT study that said that the capacity of the remaining lane of an interstate highway was 1,300 vehicle per hour. But the highway capacity manual said that the capacity is 1,500. So we split the baby and used 1,400 vehicles per hour. And so the medium traffic that, again, wants to divert off the interstate is the interstate volume minus 1,400. And that's for the medium traffic. You know, sometimes on I-95, we encountered, you know, areas where the volumes were below 1,400. And so in those cases, we would just say that no traffic would want to divert. But in cases like that, we still wanted to provide some kind of traffic for our analysis purposes for a medium LLPMD. And in that case, we just used half of the exit ramp's capacity. An important thing to remember is that the numbers that we've been talking about for detours is the amount of traffic that wants to divert. But you know, our amazing insight was that you know, the number of detour traffic is limited by the off-ramp capacity. You just can't shove, you know, 2,000 vehicles through you know, one lane stop controlled ramp. So, you know, at the end of the ramp, you may have unsignalized intersections, you may have signalized intersections. So the ramp capacity on a, I'm gonna clear my throat here for a second. For a unsignalized intersection is, you know, is determined by the traffic that's on the main line or the road that's at the end of the ramp. So to get the detour volume, what we did was divided the movement volume by the volume to capacity ratio and then subtracted out the regular volume. For the signalized intersections, a little bit more iterative. We just did an assumption that you know, the ICM ICM action plan would be implemented, and the cycle length would be jacked up a lot. So we did just a rough high cycle length and modified the split to maximize the flow off of the ramp. And then what we did was divided the volume for that movement, divided it by the volume to capacity ratio to get the detour volume. So now we've determined a detour volume. We know that there's going to be losses over the course of the detour route, but you can't really predict that too well. So for the worst case, we just stuck with the volume that we determined, and we said it's going to go through the entire network or the entire detour. There were some exceptions to this, especially going through Benson and Dunn, where you have a grid network to some extent, and people will filter that network. Okay, so getting back to the detour volume. I apologize for having to clear my throat. Here's a curveball for you. What time period do you use for the TMCs? You don't know when the accident's going to happen. So what do you use? Do you go with a worst case scenario, say PM peak? Or do you use, say, a midday volume that is probably more representative of the day as a whole? We decided to go with a midday traffic level, just because it does cover more of the day, or is more representative of the day. And then also we figured that the detour traffic is going to overwhelm any local traffic that you have. Moving on to timings, I don't have a little entry for that, I don't believe. We used existing conditions. We used midday timing parameters, again, because you don't know when an accident's going to happen. So we just use midday because that generally is representative of a larger chunk of the day. And, something interesting or different from a regular signal timing project is that you have isolated signals, and so they run free. Okay, so moving on to existing model development. Again, with a signal timing project, it's very defined and usually a relatively small geographic area. Whereas with an ICM project, at least this I-95 ICM project, we had a huge network. Initially I thought it'd be cool to build a synchro model of the entire, ICM project and see how it would run. Well, the answer was not well. So we did end up building a master network, but we broke it down for individual route analysis. Another difference between a signal timing project and ICM is that, with signal timing project, you use true traffic runs and observations to calibrate the existing network. But with ICM project, you can't calibrate. Your volumes are estimates. You just can't sit out on a network waiting for an accident to happen. So you just go with what you got. In one case, we had previously done signal timing and done, so we had a calibrated model for that. But from a calibration standpoint with ICM, it's kind of a shot in the dark. Moving on to optimization. With a regular signal timing project, you use your microscopic software programs, synchro true traffic to optimize your cycle links, splits, and offsets. And then, run sim traffic to validate the model and make adjustments and stuff like that. With the ICM project, we're dealing with some seriously high volume to capacity ratios in some instances. And, synchro just doesn't do too well with highly saturated situations. So we ended up doing a lot more simulation, especially with everything, but especially with isolated signals. And, with synchro, recommending a cycle length of 60 seconds for an isolated signal to handle, 2,000 cars coming down the pike. We just ended up just arbitrarily, choosing, 120, 150, 180, 210 cycle lengths, and we'd run 3 simulations and see which one provided the best MOEs. Moving on to timing parameter preparation. So another big difference here, with a signal timing project, you generally have 4 to 6 plans that fit nicely, in plan 1 to 10 on Syntrax or Oasis. But with ICM, we had to provide a system of plan numeration that was with the end user in mind, the STOC and the TMC operators. And this is just us. I don't know what the other other firms have done with the other ICM projects, but you got 64 available coordination plans, and a great majority of those coord plans are never used. And so what we did, we consistently assigned the coordination plans, 20 through 29 of all the LLPMDs that were geographically northbound, 30 to 39 for eastbound, 40 to 49 for southbound, and 50 to 59 were westbound. In other words, 2 was always an integer, the first integer for north, 3 for east, 4 for south, and 5 for west. And then, there's 6 possible LLPMD cardinal directions that are associated with each direction. So you got, a left medium level, you have a high medium level, you have a medium straight and a high straight, medium right, high right. And that would fall into the second digit. So example, your left medium would always have the second integer of 0. Left high would be 1, through medium 2, through high 3, and so on. Moving on to implementation and fine tuning. The difference here is with a signal timing project, you implement on site. And then with ICM, what we're going to do is with the wonders of Syntrax, we're going to implement from the comfort of our quote office and make sure that the signal timing plans kick in and nothing blows up. And we're going to do that late at night. And then with fine tuning, again, you're out on the street corner, you're observing, and you're making adjustments to the splits and the offsets and stuff like that. Whereas with the ICM project, we're going to have after action reviews and get an earful maybe whether things work or not. So with that ends my presentation. I am curious as to how the public's use of the navigation apps is going to affect these ICM projects. We've seen in some signal timing projects that, we implement signal timing, we've improved things, and then we come back a day or a few weeks later, and seems like the navigation apps have directed more people onto our route, and thus made things a little bit not so great. So with that, questions or crickets?
We had one quick question, and we need to speed up a little bit. Sorry, just because we still have 2 more presenters. We only have 20 minutes. Was dynamic max for priority movements considered or implemented at isolated intersections? I know, well, Matt says no. He's shaking his head. We did put some of the coordinated movements, so we did some of the signal timing as well. We did put some of the coordinated movements on max recall to make sure that they did not gap out or have any other issues, like say if it was a left turn, but not a dynamic max.
Yeah, I don't think we had any discussions about it. I don't know if Carrie or Steve or Belena, for that matter, considered or thought about doing it, although we never discussed it. I think of dynamic max as more for, and I think it could still be applicable here, but it's almost like a really soft, I guess, traffic responsive. And the plan here is we know for sure that we're dumping a bunch of extra traffic on it. I still think that it could be useful though, because we don't know exactly how much. So yeah, it's worth something to consider, Dennis.
Okay, and then we're going to go ahead and move on. We have Doug Hayes is the Regional Traffic Incident Management Coordinator. He has been heavily focused on the tow contract program for the last 4 years. Doug is a retired captain with the North Carolina Highway Patrol, and Doug often misspells Brian's name on email correspondence. So we're going to throw him under the bus. At least he doesn't type brain. It could be worse.
Well, no, I do
Go
that
ahead,
too
Doug.
sometimes. So, Brian, are you still on here?
Oh, yeah, I'm
Brian?
here. I'm
Hey,
here.
man, let's me and you go together and liven this thing up a little bit. All right, so I've got good news for anyone that's traveling along I-95 is that instead of putting us last, we're actually at the very beginning of these ICMs. So we have a tow contract in place. And of course, we have ICMs that you guys have got a thorough understanding of now. So, I hate to throw a number out there, but the vast, vast, vast majority, over 90% or more of these incidents get cleared up prior to an ICM going in place. So, planning for this and trying to explain how the ICM, the tow contract works together is sort of tough. It's not a round peg into a round hole. So that's where Brian comes into play on lots of these things that are predetermined. Sometimes Brian is able to utilize the towers to decide whether an ICM goes in place or not. Just a few clarifications. We have 3 tow contracts across the state. Business 40 is over, so we've got one on I-26 and I-95 north of Fayetteville that's DOT administered towing contracts. And the value of them, as opposed to a rotation record system, is that we have one dedicated tower. A rotation system, law enforcement has to get there, determine if they're going to call off a rotation list, and then call whoever's next on the list. With a dedicated tow contract, we can call our tow contractor prior to law enforcement even getting on the scene. So we're getting them there much, much, much quicker. Even when we were putting this model together 3 or 4 years ago, we didn't even anticipate then how quickly we could get the towers there. So, Brian, we're kind of limited on time. They told us we had 5 minutes each. I don't know if we got the memo, so I apologize for dragging you into this, but how do you use the tow contractors to speed up your process?
Well, the tow contractors are, I mean, they're speeding that process up on their own. What I will say is that the existence of the tow contractors and the really consistent and reliable success that they're having clearing lanes quicker has made us adjust our expectations when we're building our expectations. So, like on the screen right now, there's a slide up that says, you know, the TMC operators gather the details that go into the ICM database. And, you know, if you don't put the right details into that database, you don't get the right response out of it. And most of them are pretty standard location direction, but there's one question, and that's about the estimated duration that really you have to lean on your time and your experience to make a good estimated duration. Now, normally for minor or intermediate or even major crashes, depending on like if there's multiple vehicles, overturned vehicles, heavy vehicles, if there's injuries or things like that, we really bump up our estimated duration. But like I said, since the tow contractors have been so successful getting lanes open quicker, we have to ratchet that down to a lower time frame, which sometimes means that the duration's so short that the ICM database says no ICM response is necessary, just do SOP. And so that's one of the ways that the tow contractors have really had a big and positive impact on how incidents are managed in the ICM corridors.
I guess I'm still on my information, Carrie. Or we're still in here. I kind of taken over the panel here, but anyway. So Brian, and I'm going to throw this out there to Cole too, because I know that he's sort of working on the ones for I-95 now. Yesterday afternoon, they talked a lot about the information and how things have changed during COVID, and working a lot with law enforcement. And kind of what I've seen across the state is that law enforcement is investigating a lot more traffic fatalities. There's a lot more speed involved. We have got tractor and trailer incidents that are turning over and lasting for days, whereas we're trying to track these tow contracts by minutes. We literally have a few incidents in the past several weeks that have lasted past a day on getting stuff cleared out of the roadway. So with that new information that's out there, you guys talked quite a bit about how you were looking at this data and plugging in on traffic counts and everything else along I-95 for ICMs. Have you guys looked at what's happening now as you're developing ICMs? Cole, you want me to rephrase that?
Are you asking if we're looking at the COVID?
Yeah, I mean,
volume?
are you kind of looking at the current stuff and what's going on as you're trying to shape these ICMs?
So the answer to that question is no, Doug. We primarily use the volumes pre-COVID to determine the route and the volumes for the Q thresholds, primarily because we felt like that was a longer term look. Felt like the traffic volumes would rebound, and yeah, that's what we used.
I'm going to jump in on that a little bit too. Like for the I-26 section, I know that we've had 2 after actions already, and you know, the tow contracts really got in there and moved everything. It's almost, the tow contracts are very integrated, but they almost prevent us from even needing the ICM a lot of times. You're correct, Doug. The duration is so short, and you guys get right on top of things that we don't even have to activate the ICM. So it actually works out well.
Doug, for your question, are you asking if we've evaluated implementing a new route, a new response plan based on COVID traffic being less on I-95?
Well, maybe. I mean, what's the line in the sand? Is it 30 minutes? Is that the kind of the line in the sand roughly on when to throw the switch and when not to?
It depends. It depends on the location and how many lanes are closed. if it's, for example, if it's one lane closed, one lane open, it's got to be a duration of 2 hours and hit the queue threshold.
Well, what about when we have towers that are getting it cleared out really quickly, and we've got them on scene as a means of information? I mean, they'll be pretty good about telling us how long they think an incident is. I mean, can we factor that level in to improve this process?
It's already factored in. So Brian's operators are using the database, and whenever anything changes with the condition, they input the new parameters into the database. So say we initially thought it was going to be a 2-hour incident, and they get feedback from the field, maybe it's from the tow contractor or IMAP that says, hey, we've reduced the time. We think it's going to be 30 minutes now. You can plug that back into the ICM database and see if it's time to remove the response plan. Does that help?
Oh yeah. So is that question for me, Brian?
Yeah, Brian,
Yeah.
Can you talk a little bit, or Doug, I'm sorry, can you talk a little bit about how what's the difference between contract towing and rotation towing?
Okay, so law enforcement has what they would call a rotation towing program in place, which basically they'll have a list of towers that they rotate through. It's a very fair system. I mean, it's one that, they have towers that meet the bare minimum restrictions and they get on a towing rotation list. But law enforcement will have to wait till they get on scene and then ask the folks that are involved in the crash if they have a towing preference, if they've got an owner's request, a tow service that they want to use. And if they don't, then they'll use somebody off the rotation. That takes quite a bit of time. When you have a dedicated contract tower in these areas, you can go ahead and dispatch them to the scene just as soon as, I like to say, we have a rumor of an incident. So quite often the towers are arriving about the time the other first responders are. At that point, they have the ability through the quick clearance law to get the vehicles off of the roadway once asked by the DOT or law enforcement, so they can quickly clear the roadway. If someone that's involved in the crash at that point has a preference for their individual tower, their tower can come and get the vehicle after it's off the roadway. So we're able to clear the roadway much, much quicker with a contract tow. In fact, our requirements currently is that when we call the tower, they have to be there within 20 minutes. So from the time that we call them to the time they get there is within 20 minutes, often is an hour or so quicker than what would happen under the rotation record agreements that the Highway Patrol or local municipalities use.
So Jennifer kind of pointed out something earlier that helps kind of tie these two pieces together. That towing is part of the ICM that focuses on the quick clearance of incidents, versus the other part of the ICM is the detour and alternate routes with the signal system timing when we can't clear the incidents quickly. So they really complement each other.
And that's correct.
Yeah.
Yeah, and also, of course, if you did have an ICM that's in place, you'd have the contract towers out there that the STOC is used to talking with that can help plan, how long the incident is going to be as they provide travelers information and whatnot to the general public. So it's a tool that we're basically at the tip of the iceberg on. I think that there's quite a bit of things that we can learn going forward of how we can implement more information that we can get from the contract towers as we develop these ICMs in the future.
Yep. Chad also pointed out, I'm going to point out his thing and then we'll let Brian go real quick as well. During the I-26 ICM project and construction, we were able to utilize the ICM timings in order to help with the bridge construction. So we actually put in the ICM timing plans so that they could do a rolling roadblock during the evening, which allowed them to set the large bridge beams and ended up saving the I-26 construction project a very large amount of money. So that was, plus it was fun for us to go test the ICM timings outside of, actually we had a planned incident that we knew when they were going to be turned on. So it was fun for us to go try that out. Let's take a short detour, and Brian, I'm gonna let you get into yours, and y'all, I apologize, we're probably gonna run over just a few minutes, but we'll hang on here and answer questions at the end. Brian Gunner is the statewide operations manager responsible for day-to-day operations at the STOC in Raleigh and the Metrolina TMC in Charlotte. Brian started his TMC career at GDOT statewide TMC in Atlanta, Georgia. And for the last 10 years, he's been closely involved with NCDOT's traffic operations and incident management program. So we'll let Brian jump in.
Okay. Thanks, Carrie, and good morning, everybody. I'm going to execute the express version of this presentation. So what I'm talking about today is just the TMC's perspective, the control room, the operators, their perspective on ICM. And whereas what Doug was talking about, contract towing, is where ICM, the literal rubber meets the road. TMC is the figurative, where the rubber meets the road. So far in this presentation, we've heard a lot about the significant thought and planning, design and engineering and coordination, prototyping, analysis, and things like that went into putting ICM together. All of that working towards this place where someone, a TMC operator, would be able to click the button and execute it. And we're finally at the end of that chain where there is that button and the TMC operators are the one that click it. So I've got a few things up here that say, this is what TMC operators do in response for ICM. There's a lot of other control room tasks that we're doing, all of the things that we would do for a normal crash or a normal incident without ICM. But just in general, we're also the ones that are activating all of those sign plans and traffic signal retiming. We're talking to people in the field, including DOT, IMAP, law enforcement, contract towers, etc. And one thing that we do in support of the contract towing project is we help capture those response times in order to manage the tower's performance. So we continue to see the type of quick clearance that we're really looking to get out. So this is really, there's so many benefits that ICM brings. It's such a great strategy, and I'm so happy to see us implementing it more and more statewide. There's a lot of benefits that it brings, but from the TMC perspective, one thing that is just inescapable to us is how much faster we can execute really robust and complex response measures. So a big example here is activating multiple signs with very specific detour information. Usually for a major incident like this, we're going to be using anywhere between 6 and 10, maybe a little bit more, different changeable message signs or dynamic message signs. And we're not just putting up there that says, road closed ahead, use detour. We're telling people exactly where the road is closed. We're telling them exactly what detour to take. And so I've got two different versions laid out here in this manual no ICM block. What I'm showing is the amount of time that it takes to first plan that detour and get it approved. Our operators are trained to design and develop detours and alternate routes, but in a lot of places we need to get boots on the ground approval that it's actually a good one, and that can take 10 minutes just to look at that map, investigate it for roundabouts, railroad tracks, multiple signals, things like that. And then after we get it created and approved, then we have to go through individually and click on that sign and write the message, and click on that sign and write the message, and so on. And just altogether, those minutes stack up to the point where we're probably 20 minutes in and we're finally activating this detour message. Whereas with ICM, it takes just a couple of minutes for us to submit a query through the ICM database, and it tells us what sign plan to make or to execute. That plan's already been created. It's already been approved. We already know that it's the right one. And so it only takes a couple more minutes to actually click the button and have all of those signs running. So that's just an unmistakable difference in response time. You know, like I said, it could take 20 minutes to do it manually, and it can take as little as 4 minutes to do it through ICM. That is a wow, where do I sign up sort of moment. Now, there are some challenges, of course, with ICM. A lot of people have talked about it, different challenges on the design sort of side of things. For us, one of the big challenges that we have is training. There's just simply a lot of people to train to execute ICM. A lot of good work has been done on the design side of things to standardize what ICM is, to build the same sort of tools into the process. So we're using Syntrax, for example, for all of our signal timing. That's excellent. That means that I don't have to teach Syntrax plus, you know, Acme product X plus, you know, whatever the other thing is, just to do the same job. But one of the other things, especially now that we have a few ICM projects rolling, is we'll have a crash, we'll do an AAR about it, and we'll discover some gap or some improvement. And every time I walk out of one of these AARs, I come away with at least 2 to 3 new things that I have to get into the heads of all of these different people. And it takes some time to do that, but ICM is still evolving, and so there's this there's this ongoing conversation between me and my staff about what's the new thing with ICM that we're doing now. And just briefly, another challenge just from the TMC's perspective, and I think this is actually fairly common, we're always sitting in the control room looking through these cameras at these as people are clearing incidents, and so far we're like, what are they doing? Why are they parking there? Why are there so many people on scene? And obviously the different responders have their own priorities and things that they need to do. But the ICM plan will say something very specific, and it'll say something that we know that will work, such as on the right side over here, the detour needs to go this way, and we know that, and all of our signs say that. But law enforcement or fire or whomever, it's part of their protocol to pull up and usually divert off onto the very first exit behind. Now that's not a bad thing. That's actually very good for a number of reasons for them to do that. But what needs to get augmented into this field response is somebody going back to the proper detour beginning and really divert traffic there. We see that a lot of signs will tell, our signs that tell people to take a detour, they catch a lot of traffic, but they don't catch it all. A lot of people will wait through the queue all the way up until they're physically diverted off. And so especially for I-95 ICM, they've made these really great field implementation guides that you can share with people like maintenance or DOT, et cetera, to show them where specific detours are and really get them involved in how to augment ICM response with what they're doing in the field. So it's just another opportunity, another lesson learned as we continue to implement and support ICM in other regions. So just in summary, TMCs are the ones that actually take ICM out of the thought realm, out of the realm of concept and spreadsheets, and we put them into the real world. We're really much a handshake on the design and execution side of things. From our perspective, and it's only been going on for just a little bit, but everywhere that we see ICM in place, we think it's working. I'd be really excited to see a lot more academic research done on that, because I'm sure that the news will be good. The other thing is that ICM is still evolving and it's still getting better, and the more we learn about it, the better we are about designing it and the better we are at executing it. So thanks, everyone.
Brian and Doug, thanks for cutting y'all. Sorry for cutting y'all short. Thank you so much for squeezing that in at the last minute. Does anybody have any questions other than James and Chad comparing their quick clearance stats? Let's see. I don't think I've missed any questions. I want to say a huge thank you to all of our presenters. I thought we were going to be done in an hour and a half, and we ended up going the full 2 hours. So that's what I get for thinking we were going to cover this too quick.
Hey, Carrie.
Yes.
There's one question early on, I think, during my presentation that I wanted to come back to if we have just a second.
Oh, yes, please. Go ahead. I forgot.
Just maybe a
Yes,
minute or
please
two
answer
to
Sean's question.
Yeah, for Sean. So he asked if, let's see, wants to hear more details on the new thoughts on signal timing strategies that I mentioned. So Steve gave a good overview of how we've been, pretty well good overview of how we've been designing our sort of philosophy with our signal timing, and it's kind of been picking a time period of the day to base the existing traffic on, and then dumping a bunch of extra traffic on it, and kind of coming up with like a moderate and a heavy set of plans that we generally use whether the road is open or closed. And I think that has worked pretty well. And I think, though, what we'd like to do is and we've had to do that out of necessity because we were previously coming up with all the signal timing before we really made decisions about if and when we're actually going to use that signal timing. So what we're trying to do now is make the decisions on the front end so that before we are actually designing our signal timing, we know what we want to use signal timing on this route on these times of day, and we're not going to use it these other times of day, or maybe on certain routes we're never going to actually use the signal timing. So the two-pronged benefit of that is, one, we don't design signal timing that we never use, which has happened on some other projects. We design some things, and then after we actually make the decisions, there are some plans or routes that don't actually ever get used. The other is that we can hopefully design those plans with a little less broadness and with a little more specificity, because we know we're only going to use it in the AM or the PM, so we know the directionality of the prevailing traffic before we add the extra traffic on it. Essentially to have those plans a little bit more catered to what's actually happening on the ground, and a little bit less kind of general and generic.
Thank you for doing that, Matt. Were there any other questions? I'm trying to scroll through right now. Was there anything else that anybody had questions on? And I don't think I saw any more in Hoover either. Let me check there real quick. No, I think we're good. Well, thank you guys so much for attending this session. I really appreciate it. Thank you to all of our speakers. Just a reminder, we have another session again from 2 to 4. So go grab a quick lunch and come back. And then don't forget to join us at 4:30 for vendor networking and or happy hour. Thanks, everybody.
Thanks.
Bye, everyone.